Sorry I had to be out again, but since I couldn't be there in person, I wanted to make sure I could still be part of your lesson. So I'm going to talk you through the worksheet that you have in front of you. Hopefully you've already given a try for these first 4 problems. These are very similar to what you saw yesterday in the video and in the practice we did in class. I know some of us were feeling pretty comfortable, some of us were having a little bit of trouble, so we're going to start with a couple of these. Remember, each one is kind of reading through the problem and looking for that key vocabulary that signals what we want to accomplish in the problem. So our first one is 6 more than a number. Well, to begin with, anytime you see the phrase a number, well, that means we don't know what that number is, so that's where we want to plug in our favorite variable. Our variable stands for the number we don't know. What are we trying to figure out? Then we look at the rest of the problem. 6, well, that's kind of obvious. And then we have the phrase more than. If you remember from your notes yesterday, the word more than means to add. So we simply write it as 6 plus w. 6 more than a number means 6 plus w. Next one, the difference of 8 and k. Well, the word difference is really code for subtract. And remember, in almost all cases, we're going to leave the pieces in the order that they were in the problem. 6 came first and then w. Here, 8 came first and then k. So all we're going to do is put the subtraction in between. 8 minus k. Next one, 19 is less than g. Every time you see the word less than, I want you to get used to putting that little double-headed arrow over it. It's a little reminder that this is the one time where we're going to kind of mix things up. We're going to kind of reverse the order of the problem. Instead of 19 minus g, because less than means to subtract, we're going to reverse the order of it. We're going to do g minus 19. All right? And if you think about it, say you put in a number like 20. 19 less than 20, well, that would be 20 minus 19, which would give us an answer of 1. Our brain naturally knows to put this second number first if we use real numbers, but sometimes with the variable there, it's not quite sure. So that double-headed arrow helps remind us that anytime we see less than, we're going to reverse the order of the two parts in our subtraction problem. Last one down here, 9 more than the quotient of 7 and a number. So we know more than, that showed up in our other problem, addition, and we have our 9, so we'll do 9 plus. And then we have a longer piece, the quotient of 7 and a number. Again, if you see the phrase a number, we don't know what it is, so we're putting our favorite variable, so let's maybe pick y this time. And then we look at the word quotient. Well, the word quotient is really a fancy way of saying divide. Well, we want to divide 7 and y. So we simply write 7 divided by y. Or sometimes you'll see me write it as a fraction. 7 over y means 7 divided by y. So 9 more than the quotient of 7 and y. So hopefully that was a warm-up from yesterday. So let's take a look at a couple more. We're going to start to get to some more word problem type ones where we're going to have to do a little bit more kind of investigation to figure out what we want to put and where. So this one says, write 3 more than 4 times the cost of a pretzel as an algebraic expression. We got the same one there in the middle of your page. So let's break it down. The word more than, we're getting good at that one. That means to add. So 3 plus 4 times the cost of a pretzel. So ask yourself, did they tell me the cost of a pretzel? No, in this case I don't know how much the cost of a pretzel is. So whenever I don't know something, that's where I put in my favorite variable. So 3 more than 3 plus 4 times the cost of a pretzel, or 4 times p. Here's where some of us are going to have different things, and this is where you're going to need to go back and change it. I don't want to see 4 times p, because now I don't know if that x is a multiplication sign or if it's a variable in there. I don't even want to see 4 times p. That's kind of 5th grade notation. We want to get to the point where we're simply writing 4p, meaning 4 times whatever the pretzel cost is. I want you to get in the habit of anytime you're showing a number and a variable being multiplied, they get written right next to each other with nothing in between. I want you to start to get to the point where you just know that that's what that means. So let's try another one. 2 less than 6 times the cat's weight as an algebraic expression. Well, less than we know means to subtract, but we also know that this is going to be one where we're going to flip things around. So instead of doing 2 minus the rest of the problem, we're going to do the rest of the problem minus 2. So the minus 2 is going to flip to the end of the problem instead of the beginning. Now we have the second part of the problem, 6 times the cat's weight. Well, I have no idea how much the cat weighs. I'm not even sure why we care about the cat's weight in this problem, but that's the problem we got. I don't know what the cat's weight is, so that's where I put in my favorite variable. So how about W for weight? And I want 6 times the weight. So 6 times W, which we just talked about, we would write as 6W. So no dot, no X in between there. All I will accept is 6W, 6 times W. And then less than 2, meaning minus 2. All right, hopefully you're starting to get a little bit more comfortable. Let's tackle the last couple, and then you're going to do some practice today. So this one said, Sam, who I hope is paying attention, bought a box of popcorn for $3.50 and 3 medium drinks. Write an expression to find the total amount they spent. So Sam must have gone with some people. He bought 3 drinks, and we want to know how much they spent. So we know that they bought popcorn for $3.50. So $3.50. And 3 medium drinks. Well, think about what you do with all the prices when you go to the movies, or you go to Target, or Walmart, or wherever it might be. You add the prices of everything up. So it's going to be $3.50 plus the cost of our 3 medium drinks. Well, let's take an example. Say each drink was $1. If I bought 3 of them, we can all say, oh yeah, it's going to cost us $3, because we know to do 3 times the cost of the drink. We don't know what the cost is, so we use our C, or our variable, to represent it. But I know if I'm buying 3 of them, I want to multiply the cost times 3. So that's all we're looking for in this problem. We know we're going to pay $3.50 plus 3 times whatever the cost of the drink is going to be. So $3.50 plus 3C. Simple as that. Let's try one more. It says, Micah goes bowling on Saturday afternoons. She bowls 3 games and pays for the shoe rental of $2. Write an expression to determine the cost of her bowling on Saturday afternoon. So apparently Micah goes pretty often. She likes to bowl 3 games and then pays for the shoe rental of $2. So she's got to pay for both her games and shoes. Well, we know she's going to pay $2 for the shoes. And we know that when you're calculating prices, you add the prices of everything up. That's how they get your total. But what we have to figure out is, what about 3 games? Well, it doesn't tell me how much each of the games cost. So that's the part we're missing. That's what we're going to represent with our variable. So maybe call it G for games. And we know she bowls 3 of them. So say she pays $2 a game to bowl. Well, 3 games would be $6. $2 for each game. And we figured that out by just multiplying the number of games, 3, times the cost of the game. Well, if G is the cost of the game and I want to bowl 3 of them, I just find 3G, or 3 times G. So my expression is 3 times the cost of the game, 3G, plus $2 for the shoe rental. So we're just piecing it together. We're not always going to have those same keywords to look for, so we have to kind of picture how would we calculate this in a real life situation, and then we piece the parts together as we go. All right, good luck.